Chapter 3 Practical Electronic Circuits. You're not expected to know a great deal about various electronic circuits used in an amateur radio to pass the novice class exam, but you must be familiar with a few basic circuits. This chapter you will learn how to calculate resistance capacity in a given circuit. You'll learn the filters or use electronic circuits. You will learn how to draw simple power supply circuits, amplifiers, oscillators, finally exposed to the various methods of the keying transmitter. The longer portion of the chapter of the devoted oscillator circuits will an examination may be as one type of the oscillators, but which one? Whether we'll have to memorize the circuit. Here's where you will have to memorize the circuit. This is done like a little hard study, looking at how the transistor electron tubes connect with the circuit, but you're able to identify the circuit's name with the Hartley, TPTTG, Colpitts, etc. Answers given an example of the operation of each circuit. The sample of questions prepared by the FCC appears at the end of the chapter. 3.1. The voltage applied with the circuit doubled with the resistance of the circuit increased 3 times, and the original value of this would be the final current, with the final current value of 2/3 the initial value, with doubling the voltage across the current increase with the resistance to cause reciprocal change in current. If the vacuum filter tube having filter rated at 1/4 of an amp with a 5 volts operated with a 6-volt battery, which is the value necessary to see the dropping resistor. Resistor drop of 1 voltage current over the resistor will be at 0.25 amps. 2 of the values necessary to calculate with the drop of the ohms and the voltage equals 1.0 amps, 0.25 in this case of amps. So the voltage divided by the amps is 4. So the value of the resistor is 4, and if the resistor of 3, 15, 15, 3, 5, 15 ohms connected on the parallel, the total resistance of the parallel equal to the reciprocal sum of the individual values are 1 over the resistor 1 over resistor 1 over 1 resistor 1 plus 1 resistor 2 plus 1 resistor 3. So we'd have 15/9 or 1 2/3 of an ohm. If the 30 ohm resistor replaced with a 2 15 ohm resistors in series would be the effect of the total circuit. The resistance don't affect in series circuit. Total circuit resistance is equal to the sum of the individual resistance equation. Resistor total of each resistor 1 plus resistor 2 plus resistor the number. Subscript n denotes the number of additional resistors that might be in the equation. Therefore, by replacing 30 ohm resistor with a 2 ohm to 15 ohm resistor will not change the total resistance. 3.5 given 3 parallel resistors, 200 ohms, 380 ohms, and 40 ohms. The final equivalent resistance of the equation are 9.23 ohms, with the equivalent resistance with a 220 ohm, 30 ohm resistor connected in parallel. The convenient formula the equivalent resistance total per parallel resistance of the equation shown as 1 over 1 over resistor 1 plus 1 over resistor 2. Therefore, finding the LCD, the lowest common denominator, it was resistor total is equal to 1 over R2 plus R1 over R1 times R2 with the total, taking the reciprocal as R1 times R2 plus over R1 plus R2. The equation product sum of the formula equivalent committed in memory. Solution 12 ohms. Millimeter full scale reflection milliampere with a resistance of the 250 ohms was used to measure the unknown current shown with a meter of 4 ohm resistor with a meter indicating a 0.4 milliampere would with the actual current value. The current individual resistance inversely proportional ratio of the resistant value ratio's value at 25 to 4 or 6.5, 6 and a quarter. Thus the value is shown with a 6.25 value with indicated with a meter. 6.2 times 0.4 is 2.5 milliamperes. The value through the meter is the additive of the parallel value is shown as 0.4 plus 2.5 or 2.5 milliamperes. In the circuit shown in Figure 3.1, so over the total of the circuit resistance, total circuit current voltage across each resistor current through each resistor. Closed examination circuit shows only the quality with the computed with the given information equivalent resistor 2 and resistor 3. However, the one quality is known when it can be added with resistor 1, obtaining the total resistance circuit of the formally found with equivalent resistor of 2 parallel resistors. Only total resistance known at total current is of the Ohm's laws. Amp is equal to the total voltage over the total ohms. So we'd have amp total examined with the total current of the 30 amps seen in 3 amperes seen as flow with the resistor 1, 80 resistor voltage across the resistor. Thus, the voltage of the resistor 1 amp total of the resistor 1 is 3 times 8 or 24 volts. Since the 60 volts applied with the circuit, the 24 over the 60 volts over the cross of the drop of the resistor 1 voltage 36 will drop across 2 parallel resistors. Resistor 2, Kirchhoff voltage law of through current 2 and 3. 3 amp of resistor 2 is equal to the voltage of resistor 2 over the ohms over 2 resistor 2. So we have 36 over 20, 1.8 amps. Resistor 3, voltage resistor 3 over resistor 3, 36 over 30, 1.2 amps. Having calculated all the current and voltage of the complete description of the operation circuit can be made, the total of 3 amps leave with the negative terminal of the battery flow with the 8 ohm resistor. Doing the voltage drop to 20 volts of the cut off of the resistor with a 0.8 with 3 amps of current that divides over the two currents over the total of the 1.8 amperes flowing through the 220 resistor with the current produced with the 36 volt with the drop at the 20 ohm resistor with the remaining current 1.2 amps over the point A down to the 30 ohm resistor point B. Current produces voltage drop of 36 volt with the cut off 30 ohm resistor with the notice of the voltage drop of the cut off of the 20 ohm 30 ohm resistors are the same. Two branch currents of 1.8 and 1.2 amps combined at junction B. The total current of the 3 amps flows back to source over the action of the circuit has been completely described with the exemption of power dissipation when the necessary could be computed with the methods previously shown. Combination circuit not difficult to solve. The key is solution known if the ordered and step of the solution must be accomplished. Capacitor 1, 3, and 5 UFrads connected with unparalleled total capacitance. The total value of 9 UFrads. Capacity parallel to divided added precisely the same in the resistor series. What would be the total capacity of 5, 3 UFrad capacitors based on the question? 137 would value 1.5 picrofarads. The idea of the converter with the fractional value of complaint common diameter of the added with the value of the together with the common diameter 105 of the reciprocal value of capacity at 21 over 105, 35 over 105, and 15 over 105. These add up to 71 over 105 or 6.76. Reciprocal at 60706 is 1.48. Having the available number of capacitors rated with the microfarads at 400 volts each, have the necessary to obtain of the combination rated at 1.5 microfarads and 1.6 kilovolts. The 12 capacitors placed in series with the equivalent distribution voltage capacity combination 4 2 microfarad capacitor series with only with a half of microfarad, since paralleling shows a pure sponge lead and a lead peroxide capacitors added capacitance value of 3 such strings resolve with a total value 1.5 microfarad, 1.6 kilovolts. Connecting capacitor series with good idea to play for the high resistor value across the capacitors along with the resistor same value with the voltage across the capacitor evenly distributed, neglecting excessive leakage. 312. The hypothetical 6 over the voltage store would have an internal resistance of a tenth of an ohm with a current flow of a 3 watt lamp. The proper voltage rating is connected. Remember, the internal resistance of the battery must be taken into consideration because of the pattern of the circuit adjusted with the resistor shown on the power of the battery. 3 watt resistor of the lamp with a drawn at a half an amp with a 6 volt serve of the amp is equal to the watt over the amp voltage of the source of voltage drop is 1.10 resistance based on the watting of the ramp wattage ramp. The resistance of 12 ohms over the resistance is equal to voltage squared over the power. Series resistance of 12 ohms plus a tenth of an ohm or 12.1 ohms law currently equals 6.6 divided by 12.1 or amps over the voltage over the ohms or 0.496 amps or 4.96 milliamperes. Generally, why are all filters use the band stop high pass, low bypass filter, high pass and low pass filters used? The drawing schematic most commonly used filters. Filters use control of the frequency transfer from one circuit to another. Much of the filtration paper used for the control of the amount of impurities calculating automobile's engine. Band stop filters refer to the band rejection filter as shown in Figure 3.3 with the band resolution resultant frequency flying with a series of the resistance circuits, series S and S, low impedance path of the parallel resistant circuit P with a high impedance path of the resonant band. Frequencies rejected with the shot into the ground. All other frequencies of S and S high impedance path and P lower impedance according to the past input to output little opposition. Figure 3.3 with the resonant band frequency with a parallel resonancy parallel P and parallel P high impedance path and series resistant paths of the low impedance resonant band frequencies pass with the input and output little opposition, while other frequencies of parallel resonant circuit series of low impedance and series resonant circuit to the impedance path according to frequency other than those desired rejected. Figure 3.4 shows the basic low-pass, high-pass filters. Figure high-frequency input for the relatively high inductancy band rejection filter, and band bypass filter. 3-4 shows low pass, high pass filter. Show the input of the inductor, the capacitor, low pass filter, input capacitor, low output, and the high pass filter. Time reactivity of the inductance with the low capacity over the capacity with the frequency stop with the inductance short circuit with the capacity, the low frequency with the meets the little opposition with the inductance high opposition with the capacity with these low pass filters typical using the radio frequency output circuit with the transmitter prevent transfer with the harmonic spurious frequencies. Figure 3-4 show with the basic high pass out filter with the theory of the operation is basically the same with the low pass filter except filter offers little opposition frequency above the design frequency with the high opposition frequency below the design frequency. High pass filters are such placed for the television receiver to prevent pressure of the TV set frequencies below the television band. Amateur for the radio services might otherwise cause interference with the receivers. If such device with the operating completely close the butt below the lowest desired television frequency schematic shown in Figure 3.5 that illustrate with the pi type of the low pass filter, high pass filter. 3.14 draws a circuit diagram of a low pass filter composed of the constant K and the M derived section. With the constant K filter conventional RC filter of the R has been replaced with the inductive element with the resistor has been replaced with the inductive element M derived filter, one of which with one capacitor inductor elements with the converted in the tune circle with the term that M is variable with the design filter that refers to the ratio of the filter cutoff frequency with the resonant frequency with the tune circuit. Figure 3.6 show with the constant K parallel resonant with the variable design filter ratio derived series resistance of the variable ratio of the design filter frequency resistant frequency tune circuit filter networks. Capacitor is placed in the cross of the two inductance with the top of the left filter shown. Low bypass filter becomes a combination of the variable design filter ratio derived with the tune circuit with the constants of the K with the series inductance shown in its capacity network. And both inductors are shown with the capacity of the filter become with the ratio of the capacitor derived filter shown in the lower left section with a incomplete inductancy, parallel capacity, parallel inductancy, make constant series network. Section shows the type of low bypass filter, high bypass filter. 315 listed with the many advantages of a high full wave rectifier compared with a half wave rectifier. Ripple frequency with a pulse with a DAC output signal with a full wave rectifier with a choice of half of the wave with a rectifier. Thus the output voltage is easier to filter. Also some of the transformer supply with a rectifier use the full cycle rather than one full half cycle. Both voltage and circuit efficiency increase with a non-performance operational penalty. Drawing a diagram each of the following proper supply circuits explaining the operational included with the relative input-output voltage, amplified wave shapes, and current waveforms. You have two inductor capacitor, low pass T section, and two inductors of capacitor and inductor low pass here with a derived with the T section, and then we have a low pass shunt with a derived with the T section. Vacuum tube full wave rectifier capacitor with an input of pi section filter. Vacuum tube full wave rectifier choke input filter. Type of the full wave supply with capacity with the input and section of the drawing. Figure 3.7 show with a complete for the power supply with a step up transformer output line. Each section with the label to describe according with the function immediately below with the diagram section of the waveform representing the output voltage. Each section shown in the transformer section supply driven from a 115 volt primary power line transformer shown in the windings. One rectifier with the filaments of the older than the high voltage rectifier set. Each allowed with the current pass in one direction over the pi section filter the meaning for the because of the shape of the notice for the resemblance between the filter and the Greek letter pi with the regulator of the voltage derived by the section of the note required with the question with the presented all better understanding of the power supply circuit done with the section of the ability of virtually any of the power supply. For example, the transformer section U with any of the various power supply with the configuration filter with the competitive with the input type with the inapplicable the power supply circuits have the full wave, half wave, and full wave. The explanation certain functions shown with the drawn applicable the other illustrating power supply types expected as noted. Figure 3A show the basic power supply circuits. Should be noted the diode assemble the air with a perpendicular line crossing point with a baby U of the diodes, either vacuum tube with the silicone and the silicon current construction. These supplies with a picture over the applicable either silicone or vacuum tube circuits. Tube type volt wave supply with a choke input filter. Diagram the supply with a precisely same as shown in figure 37 with an example of the 10-year microfarad capacitor removed with the filter section of the check with the input filter result with a slight reduction in total supply voltage, better regulation when regulator section is not incorporated in the supply capacitor voltage. The input filter produces the terminal voltage nearly equal to the peak value with the applied AC as the load increased. However, the terminal voltage becomes with the current withdrawn with the load prevents the capacitor retaining the full charge as shown in figure 39. Output voltage of the capacitor input filter depends substantially drain over the load as long as the load is quite little and constant output voltage relatively stable. The variation in load and their cause variation output voltage. The capacitor input filter thus said to have the relative poor regulation. Those figure 39 choke input filter output voltage relative constant long as load is above with a certain minimum value. The output voltage remains especially same over the wide range of the current drains. Choke input filter said with a good regulation. 3.7 the draw with the schematic include with the internal resistance of the battery resistive load. Voltmeter connected across the terminals good at 1.5 volt dry cell with a reads of about 1.5 volts. Same cell inserted with a complete circuit with a voltmeter reading of a decrease of something less than the previous 1.5 volts. Different terminal voltage attributed to the cell internal resistance with the opposition of the current offered with a cell electrolyte. All source electromagnetic force have some form of the internal resistance caused with a drop in the terminal voltage. Current flows through the source, increasing terminal voltage attributed with the voltage drop across with the internal resistance principle. Illustrated in figure 310 with the internal resistance of the battery is shown. Figure 310, the internal resistance is indicated with addition of the resistor series of battery. The battery is internal resistance enclosed with a dotted line schematic diagram. When the switch opens, the voltage across the battery terminal reads 15 volts. The switch closes, the current flows, and the voltage drops across the circuit with the circuit current 2 amperes called the voltage drop of 2 volts across the resistor 1 and 1 ohm. Internal battery resistance thereby drops the battery terminal voltage of 15 volts. Internal resistance can be measured by ohm. In the attempt to do this with the damage of the meter, 318 draws a simple schematic diagram, single stage transistor amplifier radio. Alright, show the transformer, the rectifier, the filter, and the regulator, and the bleed regulator voltage. Circuit in figure 311 show the basic single stage class A radio. Show the rectifier bridge, the transformer. So we have a half-wave circuit input filter, half-wave centered end tap in turn capacitor input, full-wave double capacitor input, full-wave center tap input, full-wave bridge rectifier input, full-wave rectifier choke input filter. Circuit to figure 311 show the basic single stage class of the auto amplifier using the transistor amplifying device. Input with a low amplitude audio voltage, normally millivolt range, with it will be amplified with a Q merit with a coupled with either with another voltage amplifier with a touch amplification with a team with an initiated power amplifier merit 1 positive positive transistor common emitter with a configuration resistor 1 serve with a collector load resistor and voltage and capacitor voltage with the emitter on the emitter bias stabilization network resistor basis bias limits for the bias current with this there establishes operating point and the value shows output voltage choke input and capacitor input filter rectifier peak out voltage. Shows the internal resistance of the battery. Shows the voltage at 15 resistor 1 ohm. Emitter voltage at 15 volts. Resistor switch at resistor 1 at 2 ohms and resistor at 0.5 ohms and 0 amperes, resistor 4 ohms, and then over here 13, 15, 1 ohm, 22, 4, 2, and 0.5. Coupling capacitor to show the good region of the response of the voltage constant current applied with the circuit with the current flow through the base emitter junction as well with the voltage forward with the base of the input circuit. Draw a simple schematic diagram transistor Hartley oscillator circuit shown in figure 312 with a shear with a Hartley oscillator feed with a positive negative transistor designating series of fed oscillation. We have chassis ground, three chassis grounds, a capacitor, resistor, transistor, capacitor, inductor, voltage, constant current, resistor, bias, and capacitor. Series fed Haley oscillator, oscillator cube, mirror, resistor, capacitor, taps, inductor, variable conductor, inductor 1, 2, capacitor, resistor, voltage, RFC, capacitor 3, voltage, constant current, single source, switch 1. Feedback component connecting the series of the power supply, the translator, oscillator, operator class A or B, stability with appearance, waveform, low harmonic content, major consideration, oscillator would operate at class A, efficiency primary concern, class operation, similar class C operation chosen. Purpose component transistor oscillator should become apparent with the examination schematic diagram figure 312, sine wave generated with a tank circuit consisting of capacitor 2, coil 1 and 2, and inductor and capacitor 2 with a more variable oscillator 2 with the desired frequency of the RFC, capacitor 3 with a decoupling resistor on the capacitor emitter bias stabilization network connected in series with the emitter degeneration would otherwise occur as minimized network. Draw a simple schematic of the single-stage electron tube audio amplifier figure 13 show the basic electron tube audio amplifier circuit shown on the triad of the amplifying device. Pentode could be with a voltage amplifier, normally high noise level with a pentode with a mix that's generally unstable with the amplifier, small signal, consequently small signal amplifier audio section of the receiver is normally limited to the triad electron tubes. Capacitor 1, capacitor 2 output, capacitor resistor 1 grid input, resistor signal development and returns grid to the ground, resistor 2 with a plate load, resistor K, and minus capacity K with the network should develop the current bias class A operation circuit. Draw the simple schematic diagram of the common emitter of the radio frequency amplifier suitable for the receiver of the figure 1314. Show the schematic diagram common emitter radio frequency amplifier positive negative transistor common emitter configuration in order to take advantage of the greater gain super biasing arrangement of the start of the cycle operation transistor quiescent condition electric current determined with the voltage divider over the resistor 1 and 2 with the emitter resistor 3 current flows with the negative terminal with the show of the resistor 1 2 with the ground with the value with the resistor 1 2 and 3 are true with the difference potential between the base and the emitter forward by only a few tenths of a volt. Save the forward transfer. Show the 313 show the basic electron tube audio amplifier circuit. 314 common emitter radio frequency amplifier schematic. Characteristic curve class A operation resistor 4 determine the collector voltage with the emitter base temperature with the stabilization provided with the resistor 3 capacitor 4 prevents degeneration across the emitter resistor place of the emitter of the ground capacitor 7 the neutralized capacitor the capacitor 1 2 3 and 5 bias radio frequency current with a bias for network power supply input tank consisting capacitor 1 primary transformer 1 while capacitor 6 primary transistor 2 makeup output tank with the capacitor 1 and capacitor 6 variable. The tanks tuned with the resonant with the desired frequency gang together so they would tune track simultaneously. Show a simple schematic diagram of the electron radio frequency amplifier suit with the receiver U with the radio frequency amplifier transistor radio frequency transformer match with the antenna input impedance patent over the control grid secondary transistor with a tune with the select with its frequency with the incoming signal with adjusting variable capacitor 1 resonant desired frequency resistor 1 capacitor 2 with the cathode with the bias resistor with the bypass capacitor with the resistor 2 with the screen voltage dropping resistor capacitor 3 screen bypass capacitor stabilized screen voltage prevents it from being affected by the signal super envelopment voltage voltmeter 1 grounded with directly to some circuit connected externally with the cathode with the resistor frequency transformer transistor 2 plate load coupled with the output with the next stage of the output winding of it tuned to the capacitor for the desired radio frequency output frequency. Draw a simple schematic diagram showing the tune plate with a tune grid, tune plate and tune grid oscillate with series feed plate. Refer to figure 316 oscillator tunes circuits both grid and plate circuit with advantages because that may be used equally as low as well with the ultra high frequency. Notice with the figure with the inducting plate tank circuit with a not inductive and coupled with the inductance grid circuit with a feedback situation oscillation occur with the inter-electrode capacity with a tube from grid to plate with the illustrated with a broken line shown with a grid to plate with capacity in here with a tube. 324, draw a simple schematic diagram of the Hartley triode oscillator shunt-fed plate with a shunt-fed oscillator with a direct current with a does not play, flow with a part with a tank circuit with a plate with a supply voltage parallel with a 2 with a tank circuit with a radio frequency choke with a radio frequency, single out plate supply with a DC kept with the output tank circuit with a blocking oscillator. 325, draw a simple schematic drawing of a tuned grid with the Armstrong with a tuning triode oscillator shunt-fed plate Armstrong oscillator, perhaps the oldest oscillator of all oscillators recognized early with the tickler, being the tickler winding incorporated with introducing feedback circuit plate with a figure 318 bias voltage. Positive voltage is applied with the radio frequency choke of the plate vary with the number of the turn tickler winding adjusting the feedback fraction. Question of the Armstrong oscillator shown with the numerous federal communication testing is displayed with the fact vacuum tube version with the virtually obsolete and the transistor equivalent is rarely seen. Draw a simple schematic diagram showing the tune plate with a tune grid as a triode with a shunt-fed plate. Shunt-fed tune plate, tune grid oscillator look very similar with the series fed unit shown figure 319. Only difference of the shunt-fed type of receiver the plate voltage directly from the source of the early with the radio frequency. Tunes are going to make sure the plate tank connects directly to the ground. Since core crystals equivalent resonance circuits can be either placed, they use the turn circuit and frequency control and element oscillator circuit shown figure 320 common tone triad oscillator using quartz crystal. Showing simple oscillator schematic diagram showing colossal oscillator shunt-fed plate. The Colpitts oscillator is essentially the same as the Hartley, except for the air with the capacitance each with the connected curve with the tank coil with the capacity with the combination capacitor 1 and 2 with figure 321 forms. Voltage divided with the shunt of the potential curve with the resonance circuit with the voltage end of the resonance circuit with the opposite with the polarity with the respect with the cathode with the right phase with the sustained oscillation total tank. Capacity consists of capacitor 1 and 2 with the grid leak bias combination based on the capacitor 3 and resistor grid. Drawing the sum of the diagram, tune oscillator, tune grid Armstrong triode oscillator series fed plate. Series of the difference of the shunt circuit with the part plate supply with the figure 322 bias with the plate with a tickler winding bypass capacitor bias plus positive line requiring series fed circuits. Alright, 330, draw a simple schematic diagram of the electron oscillator, actually modified version of Hartley electron coupled oscillator combination function both with the oscillator and amplifier control grid tank circuit with control screen grids, cathode form with a series of the fed oscillator screen with a grid servicing the plate with a capacitor 2 with a screen and 0 with potential, the radio frequency capacitor 3 bypass plate supply. Output tunes are going to play get served with only coupling path with the electron stream and the grid tank with the plate tank between the hence the circuit is the same. 331. Drawing a simple schematic pentoid crystal oscillator. Pentoid oscillators such as shown figure 320 with a good deal with a more common triode crystal oscillator requires far less excitation on the drive of the tube with a full power output battery. Marked positive bias. No other polarities shown. Remember the long parallel plates of the schematic battery symbol representing the positive end of the battery cell. And pentoid oscillator shown in capacitor 4 resonant value with an additive with the supply with a necessary feedback sustained oscillation. Note of the grid leak with the supplement with the cathode bias. Cell with the develop the resistor R. DC flow with the cathode plate to develop the voltage power with respect to positive to the ground. Since the lower end of the cathode resistor effectively connected with the grid, resistor 1 choke with the voltage develop the resistor appear with the grid, turn with the grid, and cathode makes the grid negative with the cathode with the amount of equal with the voltage drop with the curve with the resistor capacitor C with the bypass with the radio frequency component with the plate current with the cathode resistor. Cathode resistor must also refer to as minimum bias for plate resistor bias voltage is develop the curve every time the plate with the current flows with the oscillator circuit. Thus, the cathode bias independent oscillation prevents excess of the tube current with the oscillation stops. 332. Draw a simple schematic and transistorized shunt-fed Hartley oscillator. Remaining a disadvantage here with the Hartley oscillator, relatively large value with the direct current through the feedback portion with the tank coil. With the disadvantage may be the overcome with the variation connection with the feedback coil insulating DC component emitter current with the capacitor 1 and 3 with the shown figure 325 the oscillator derived with the name of the 5 of the feed component with the 1 is connected with the show with the rather than series with the power supply, preventing emitter current with the flowing from the feedback winding with the stability with the oscillator, improve the emitter current with the flowing with the feedback section with the tank coil with the might be requirement the inductor 1 be designed differently. Inductor 2 with the possibility with the encounter of the shunt-fed Hartley oscillator. 333 describes schematic diagram transistor coal pits oscillator schematic diagram categorized coal pits oscillator tank circle which composed of the variable tank. Induction capacity, capacitor 1 volt to develop a capacitor 2 input signal with a transistor amount with feedback dependent with the ratio between capacitor 1 and 2. Specific amount of signal with the ratio of the capacitor 2 to capacitor 1 should remain the same. The same with the easy with a fixed capacitor. The application of the voltage of the oscillator lends itself well as a permissible tuning, indicating area to core of the inductor 1. Transistor coal pit of the oscillator operated class A with the value base of the curve unnecessary with the established with the desired operating point. Determine the same voltage divider form with a resistor voltage emitter with a base emitter junction with a resistor bias with no coupling capacitor U between the base and tank circuit. DC isolation tank cool provided with the capacitor 1 and 3, therefore with a base coupling capacitor base with the RFC collector load merit 1 capacitor C providing isolation coupling and feedback voltage. Notice all that was impossible to cope with also would be series fed with the capacity of the coupling U with the feedback. The DC emitter current does not fill any portion of the tank circuit, therefore all coals oscillator shunt will be shunt fed. Capacitor oscillator until the variation culprit circuit with a 3N transistor configuration may be with the common emitter with the configuration most commonly used in shown figure 327. The capacity utilized with a stabilizing effect. Series resonant tank circuit with loosely coupled loop with a feedback loop to provide with good stability. Also with the capacitor with the tuning with usually only one of the capacitor with a not effect with the feedback ratio. And the resonant tank circuit with the tuning with accomplished with the capacitor 3, especially some using the capacitor 1 and 2 and 3. Since the total value series capacitor is always less than the value with the smallest capacitor, they assume that the capacitor 1 and 2 and the much larger than the capacitor 3 effect with tuning capacity, essentially capacitor 3 alone. Series resonant circuit capacity with the inductor capacitor 3 bias frequency determined sequencing the tank circuit with the inductor capacitor 3 should be clear feedback voltage divider which is constant with the capacitor 1 and 2 determined with the feedback amplitude, therefore changes component value of the tank circuit, therefore the negative effect of the amplitude oscillation. The tune circuit is designed to have the high merit under load conditions, therefore the greater stability with the basic coal pit oscillator all with us schematic the drawing. Grand Transient Colesbit crystal oscillator. Colpit's crystal oscillator used primarily with a high radio frequency, extremely stable oscillator. However, it may be used with a medium radio frequency. These are circuits over the piezoelectrical effect of the quartz crystal with the control of the oscillator frequency feedback provided with a capacitive voltage divider arrangement with a usually external, but maybe to provide with a transistor element capacity of the circuit that does not normally utilize tune tank circuit with a tank circuit that require with a special application. Colpit crystal oscillators operate with a Class C with a low circuit with a waveform linear, not important. Class A when good waveform linear required. For the crystal, most important advantage of the inductor capacitor network stability with the ratio of the inductor to the capacitor with equivalent circuit with extremely large compared with the conventional tank circuit with the corollary advantage of the merit is extremely high with the flux with an extremely sharp secondary advantage. Its simplicity single crystal replaces the least of the capacitor across the series of the inductor capacitor resistor circuit. Basic comedy. 3. What is the source of the power plate with the power desirable crystal oscillator stage of the radio transmitter? Load referencing with the other crystal with the circuit of the transmitter left with the plates with the voltage with the regulator with the drop of the source with the high current volt demands with the imposed on them. Oscillator frequency shift of the plate voltage change with the unknown the AM transmitter that produce the frequency modulated signal with the same power support. Use the provided the plate of the battery from the final amplifier modulator or oscillator with the case of the modulator drawing maximum current with the voice pump peaks and transmitter total power output increase with significant power drain caused the drop of the wire voltage AM transmitted undesired frequency modulation result. Draw a simple schematic with a block base grid key, cathode key, screen key. The CW radio transmission carrier with a tuned off the form or the dots and dashes transmitted code characteristic turn on transmitter purpose code keying. One method keying is turning an oscillator on and off. It may be accomplished with the opening and closing plate with the cathode circuit with the key to the oscillator should be absolutely stable. While keyed is not stable, the frequency shift with the varying note or chirp which makes signal difficult to copy. Another method of keying a block base key. Red keying is shown figure 329 329 A schematic transistor radio frequency amplifier showing block base key and the key opening with a positive supply provides a reverse bias emitter base junction, cutting off merit 1 with the key closed with a reverse bias will remove the emitter base of the junction of the merit 1 will be conducted. Electron turning tube current with a figure 329B with a key opening high value with a negative value with applied with a grid voltage 1 cutting it off. Voltage must several times value with the grid base is required with the cutoff of the prevent with the input signal with the driving tube into the conduction with the keys closed with the negative voltage remove with the grid voltage 1 connect with the resistor 2 with the prevents with the negative supply with the short circuit with the grounds with the key with closed with the black grid keying. May use any one of the several stages with the present problems high powered amplifier due to high voltage necessary to cut off the touch amplified another disadvantaged system equipment over the negative voltage amplifier stage transmitter may be the key to open and closing the plate with the cathode circuit with the key is rarely placed in. It shows the output voltage constant current with the input transistor key with the positive supply on the grounds. Negative supply input with the output with the voltage the transistor with the electronic emitter base of the key shifter. Plate circuit due to the hazard with the DC with the potential would be present across the key. Figure 330 show with the two bends with the key with the cathode circuit with the feed figure 330A show the center tapping key with the directly heat and cathode element of figure 330B with the show with the basic cathode key and directly heat cathode. Figure 330A key accomplished with the opening and closing filament transfer with the center tap line with the key with the opening with the 2 with the cut-off since it was not complete with the DC path filament to the plate. Capacitor 1 and 2 with the radio frequency bypass frequency with the radio frequency signal out of the filament transformer key lining. Figure 330B key opens and closed circuit with the key opening no complete DC path cathode to plate with neither grid nor plate. The current can flow with the tube is cut off with the screen grid keying is shown figure 331 actually combination driver stage. Final stage keying when the circuit is the keying relay may be used to prevent operator shock. Show the filament transformer, merit capacitor 2 ground and key grounded to the and a resistor and an inductor in the grid keying cathode circuits. What is the function of the circuit? And it's answer B, full wave rectifier power supply in 332. Chapter 4, transmitting signals.